Okay. So, when I ask this question, if you never deploy this VRP, maybe I will explain for you easily and to know the principle better. If you already deploy, maybe we can discuss some key points when you deploy on your project. But it don't matter. I think the VRP also is very useful protocol. Okay. Of course, maybe in some other vendor, we will use the other name, not about the VRP, but a very similar function. Why we use VRRP and which scenario we usually use VRRP? VRRP usually will be used to solve the problem of gateway, okay, of the gateway. And the name is Virtual Router Redundancy Protocol. Of course, if you deploy the VRP in different routers to provide the redundancy next hop, it also can work. But usually we will use this technology to provide the backup for the gateway. Gateway is a special definition for the terminals, right? And then let's say why we use VRP and which scenario and what's the problem we can solve if we deploy the VRP in our network. And also we have to master the configuration. And I hope if in the future you use this technology, you will think this training or maybe the video can help you a lot. The first, let's see why we use a VRP. For example, now in this topology, we have the IP address, right? PC1 and PC2, one IP address is 10.1.1.10, and the PC2 is 10.1.1.11. And about the gateway is 10.1.1.1, 10.1.1.1. Also is a gateway, PC1 and PC2. And the PC gateway were located on the layer 3 devices. Maybe it's router, maybe it's switch. And the gateway should be the IP address of this interface, right? And the PC, if they want to wait a different segment, maybe wait the internet, maybe to wait 20.1.1.0 segment, they need to ask the gateway to help us. So in this time, if your gateway is broken, maybe the power is off, or maybe the interface is broken, that means your gateway cannot work, right? So if PC1 and PC2 want to wait the different segment, it cannot because we don't have the gateway. So in this scenario, one solution maybe is you found the problem and troubleshoot successfully and then let the devices to wait the destination again. Another one maybe is you see the network failure and focus on all the time. If the devices or link is broken and to give a new one again, or maybe you configure a new gateway address and to let the other device to help us to follow the traffic. These are the solution. If we deploy the VRRP means in our network, we will provide a virtual router. And about this virtual router, there is a group. For example, like this topology. We also have the PC, but we have two switch A and switch B. Pay attention, A and B, if they configure the IP address, the IP address cannot be same, right? Otherwise, there is a conflict. So maybe someone will say, first time about two PC, I will give the IP address for switch A, like 10.1.1.1. If I found the switch A is broken, I will immediately change the gateway to become switch B, 1.1.1.2. Then I will let the switch B to help us for the traffic. So in this solution, you have to focus your network all the time. And you have to change so many configurations, right? Although maybe you use a DHCP, you have to change the configuration of the gateway and to let the client to get a new gateway address again. It's very complex. So if you deploy the VRRP in your network, That means we will create the virtual gateway. This is a logic. And in this gateway, we will let the switch A and the switch B use in the same VRRP group. And we will give an IP address for the virtual group, for the virtual gateway, for the virtual router. Maybe the IP address is 10.1.1.3. And about the PC, I only configure the gateway address of the virtual gateway. Of this gateway IP address, I will use it as a gateway address. Then we will select one is master, one is backup. And in the normal time, the master will help us to actually forward the traffic. Although the gateway address maybe is different with the virtual, it don't matter. All the PC will think my gateway IP address is 10.1.1.3. But finally, the actual IP address will be forwarded by switch A. If in this time switch A is broken, then I can directly detect the broken. I can use the VRRP to select a new master is a switch B. So the message will finally forward it out to use the switch B to help us forward the traffic out. In all the time for the PC, I will think my gateway is working all the time and my gateway IP address is a virtual IP address. And this virtual IP address can work only in your VIP group. One device is working, the virtual gateway is working. So this is the main principle of VIP. Someone say we have one brain, but we have lots of physical body. If one physical body cannot work, we can use the other body to do the work. So this is the main function of VIP. And later we will talk as a detail how to build the VIP group and how to select who is master, how to select who is backup, and then if the what's the principle, what's the mechanism, if a master is broken, something like this. So first you have to know why we use the VIP. Okay. Then let's see the principle. Like this topology, we have the IP address of the PC, right? And we also configure the VLAN, we give the gateway address. And in this network, we have two upper switch A and switch B. Sorry, I have to mute your voice now. Okay. Now we have two switch, right? And each switch we will have an IP address 10.252, 10.253. And later we will use a command and to let A and B in the same VIP group. And each group we will have the ID. For example, the VIP ID is 1. And then we will give the priority because how to select who is master and can work for the terminal. We will compare the priority. Priority higher is better. We can use the command to change the priority. And then we also have to configure the virtual IP address. And the virtual IP address in the same VIP group should be same because the switcher will negotiate the VIP packets and to finally select who is master, who is backup. And the parameter negotiation, we have to check lots of information. One like VIP ID is same or not. The virtual IP address is same or not. These two parameters must be configured same. And this virtual IP address also should be the gateway address of this PC. So when you do the configuration of DHCP in your network, the gateway parameter also should be the VRRP IP address. Okay. Then there is a virtual router, and in the group of 1, the virtual address is 10.254. This is the main parameter. And according to the parameter priority, we will select the switch A as a master, switch B as a backup. Of course, in the group, you can have lots of devices. only one device will become the master, and the rest of them will become the backup. And when the terminal wants to visit the internet, the actual path will be sent to the switch A to help us. And if the master is broken, the actual traffic will be sent to switch B to help us to follow the traffic. If all the physical devices are broken, finally the PC cannot visit the internet. So this is the main concept in the VRRP. Okay, so the master router in the VRRP backup group 1, the priority is 110. Virtual IP address is this one, and the default VRRP in preemption mode. What means the preemption mode? Later I will explain for you the preemption mode. So the relation concepts, let's see some detail. VRRP group means these devices in the virtual group, and in this group they will have the same virtual ID, and they will send out the VRRP message to select the rule to become master or backup or something else. So they must belong to the same broadcast domain. Pay attention about this part. They have to in the same broadcast domain. They cannot locate it in different layer 3 segment. And another one is a virtual ID. The range is from 1 to 255. And in the same group, when we do the configuration, they must have the same VRID. And another one is the virtual IP and the MAC address. Pay attention about this part. The first one is virtual IP must configure same in the same group. The second one, the virtual IP should be the address finally configured for the terminal gateway. The third one, for the MAC address, by default, we will provide a virtual MAC address to the client, and the value is this one. The first several bits is fixed, and the last one depends on your virtual ID. What's the function of the virtual MAC address? Because when your client to visit the internet, we have to encapsulate the message, right? Why we say if the terminal communicates with each other in different segments, we have to ask the gateway to help us. That's because we have to get the destination MAC address from the gateway by the ARP protocol. So the virtual MAC address, the virtual router will directly to use this MAC address to reply for the client. In this time, in your group, if one device is working, the virtual MAC address can reply, and all the time the MAC address cannot be changed, right? So in the client side, I will think my gateway is working all the time because my MAC address is same all the time. Okay, so this is a virtual MAC address. And another one for the master and the backup. The master is the router finally can actually forward the traffic. The backup only do one thing, to detect the master is working or not. Otherwise, I will become a new master to help forward the traffic. Okay, so this is a concept. And the priority, pay attention. When we select the master, we will compare the priority. The highest priority will become the master, and the range is from 0 to 255, but available range is from 1 to 254, because 55 we have special meaning. This one we call is IP address owner. IP address owner means the physical IP address of devices and the virtual IP address are same. So these devices we call is IP address owner. And the priority will be automatically changed to become 255, has highest priority. So if this device is working, this device must be the master. Okay, and the default value is 100. The available range from 1 to 254. 0 means these devices will never to select to become master or backup. Okay. And the preemption mode means if we enable this mode, the master acts first, we will select highest priority to become master, right? And later, if the backup, we use a command to change the priority is higher than the master. The previous master will become backup. And later, the highest priority will become a new master. So if we enable this mode in our network, the highest devices will become the master all the time. If we disable it, if the master is selected, and then for example, we change the priority or maybe to have some other options, this master will be all the time until the router cannot work. So these are different. And by default, the preemption is turned on. So in our network, the highest priority devices will become the master. And then let's see the process. First, two router or maybe two layer 3 switch connect with our network and we add the configuration. Then these devices will send out the VRRP packets. Maybe you can say this is a hello packet and carry the VRRP parameters of these two routers, like the VRID, the virtual IP address, something like this. They can negotiate with each other. And then the virtual router generation of the VRIP will become 10.1.1.1. This is a configuration from us. And compare the priority and IP address. Higher priority will become master. But by default, they are same, right? If priority is same, we will compare IP address. If IP address higher, will become the master. Okay? So later, the right one, because it has a higher IP address, will become master, and the left one will become backup. So this is a process. And the user gateway point to the virtual router. All the PC only know the IP address of 10.1.1.1. They don't care about my traffic will be finally forwarded to from 1.3 or 1.2. They don't care about it, but they only care about my gateway is 10.1.1.1. And traffic out through the virtual router. Of course, actually, the message will be sent out through the master devices. Okay, so the switching occurs automatically after a failure of the master. For example, this device is broken, and the backup listens the message all the time. If the master cannot send me the message within the time, I will direct it to become a new master. Okay, so this is the process. This is the whole process. And the next one is about the VRP packets. VRP message are sent out by multicast message. And using the devices will detect the VRP message if the master doesn't send out the message within 10 seconds, and I will think the master is broken, so I will become a new master, something like this. And the VRP packets are directly encapsulated into the IP. This is this is different with DHCP, and the protocol number is 112. Because we say we use a multicast message to send the VRP, the address is 224.0.018. Okay, so if you deploy the VRP in your network, you use a Wireshark, you can get lots of VRP packets, and this built to the multicast message. And about the VRP, we have three status. The first one is initialize. When we, at the beginning, add the configuration of these devices, the state will be initialized. And later, if the devices is the IP address owner. That means the physical IP address of devices is same with the virtual IP address we configure on the devices. These devices will immediately to become master. Otherwise, this will become backup. Okay. Of course, if both of them are not the IP address owner, we will compare the priority and the virtual and the actually IP address and select who is master. And later, if we use the command shutdown on the physical interface, the state will become initialized again. If the master receiving higher priority VRRP packets, and the master will become backup, pay attention, the preemptive mode should be enabled. When the backup will become master, within a specific timeout period, no hello message received from master. I will think master is broken and I will become a new master. Okay, so these are three status. And another one for the VRP interface checking. This is the monitoring function. What means the monitoring? For example, like this topology, if our PC want to visit the ISP and finally to select the left one to become master, the right one to become backup, right? So the traffic finally will be forwarded from the master. If the master, the devices is broken, the backup will become new one. But some scenario is the uplink is broken. So detect the device's master. I still can send out the VRP message. So the backup will think my master is working. That means all the terminals will forward to the master. If master doesn't have the routine to visit the internet, the message will be discarded. If master has the routine to visit the internet, the master will send the message to backup. So this is a suboptimal path, not the best path, right? So in this scenario, we hope we can have the mechanism. If this link is broken, I want these devices to become a master, right? To let these devices to follow the traffic. So how to let the backup to become a master? If this priority value is higher than me, I will agree that you become a new master. So this is a function of monitoring. If I detect the link is broken, I can directly minus my priority, for example, to become 90. To become 90 is lower than the backup one. The backup one will become a new master. So this is a VRP interface tracking. Okay, so this is a process, right? And then let's see some configuration here. The first one, how to create the VRP group and how to give the virtual IP address is here. Example, deploy the two devices, master backup switch A and switch B, and here is a PC. And the key command, the virtual group is group 10, and the IP address is 10.1.1.1. In this scenario of the switch A, first we have to enter the interface. Pay attention. VRP only can be used in layer 3 interface. So if you use the virtual VLAN, this is a VLAN layer 3 interface. This is a gateway of the VLAN 10 network terminals. And give the IP address 10.1.1.2, and this is a subnet mask. Then we can create the VRP. This 10 is a VRID. And another one, this is IP address. This is a virtual IP address, 10.1.1.1. Pay attention about this part. If this virtual IP address you create is 1.2, switch A is the IP address owner, will immediately to become the master. Okay. And about the switch B, also you have to give the IP address 10.1.1.3 and create the VRP group 10 and IP address 10.1.1.1. Okay. And then compare 10 and the IP address only consider the IP address, the switch B will become the master. But we hope switch A can become the master. We can change the priority and finally to let A to become the master. And how to create the priority? VRRP the group and give the priority. You can write the priority from 1 to 254. The default value is 100. So on switch A, you can add another command, VRRP10, the priority to become 105. But about the switch B, you don't add any command of the priority. That means the default priority is 100. As a result, switch A will become the master. Okay. And another one, you also can add the monitoring function. Also is on the switch A. Because about the switch A, finally will become the master, right? The command is VRRP10, check the faster interface 1/0. This is the interface of the upper interface of this one. Okay, and this is a priority 10. The function is like here. Configure monitoring interface of switch A. If the interface /1/0 is down, the priority value will be reduced by 10 to become 95. You will find 95 is lower than 100, so switch B will become a new master. And the command to maintain the VRP, the main one is show VRP brief. And here we can see lots of parameters. The first one is the interface name, for example, VLAN 10, and what's the VRP group number, and what's the priority of this interface, and what's the time. Switching time out, that means if I don't receive the message within 3 times, I will do a new selection. And the owner will have this characteristic. That means switch 1 is not the IP address owner. And this is a preemption mode. Now we enable, so this value is P, and switch 1 is a master. Master address is 10.1.1.2. The group address is 10.1.1.1. This is a virtual IP address. And the virtual IP address should be configured as the gateway of the PC. Okay, so this is a basic configuration and a basic maintenance command. Not very difficult. But if you use VRP and MSTP together in your network, it will be a little complex. VRRP also can provide load balance. About this one, I don't explain the configuration. I only tell you what means the load balance for VRRP. If we don't add the load balance, for example, switch A is a group 1 master, switch B is group 1 backup. In the group 1, this segment 10.1, all the message will be sent out through switch A. So the switch B is not working this time, and waiting switch A broken. So this is the resources waste. But you can provide the load balance means you can create a new group 2. And group 2 is a segment of the 20. And then in the group 2, switch B is a master. Switch A is a backup. So the information of 20 seconds, I will use the switch B to force the traffic out. So this we call is load balance. But sometimes you can say this is active plus active because you have 2 groups. Okay. So that's all about VRRP. Not very difficult technology. And here are some questions you can see and choose. Which of the following is not the correct priority? What's the answer? D, yes. We can configure the priority from 1 to 254, but 255 also is a correct priority of the VRP, but you cannot configure it. This is a D. 2. What is the default value of the priority for the router? What's the default value? 1. C. 100. Yes. The default value should be 100. Yes. Should be 100. Okay, so there are some default value. I think if you have chance to deploy the VRP technology, and after the training, I will send the video to you in the project, and you see the video. I think it will be better for you to understand. Okay. And this traffic, we talk something about the VRP, why we need to deploy the VRP, what's the function. This is a backup technology for the gateway, especially for the terminals. And in the VRP, we have lots of concepts, right? VRP group and the virtual ID, virtual IP, virtual MAC address, who is master, who is backup, and maybe we also have the preemption mode and what's the scenario of this mode, and another one for the VIP load balance and how to select the state of the master and the backup. We also have this process, create, compare the priority, and if highest priority is better, if priority is same, because by default the priority is 100. If priority is same, we will compare the IP address. Big IP address will be master, something like this. So this is the configuration of the VRRP. Do you have any questions? Any questions of the VRRP? No more question? I also want to get some feedback to you because tomorrow we will begin to talk about the routing information. Tomorrow we have two topics, one for static and direct route, and the second one for dynamic route. We will talk about the OSPF. Do you think this topic is too difficult for you to understand or not? If you think it's okay for you, please write down 1 to let me know. Hello, guys. Do you think this technology is okay for you? Okay. Yes, because I think first day I can get lots of feedback from you when I ask questions, but recently there's less feedback. I'm confused if this topic is too difficult for you. If this topic is okay for you, maybe tomorrow is the same time at 2 o'clock to 5 o'clock. And tomorrow we will talk about the routing information. And last day we will talk about the NAT and ACL. So that's the topic of this week. And next week we will discuss something of the wireless. So if you don't have any question of this topic, maybe that's all for today's training. Thank you guys to join.